Station, this is Houston. Are you ready for the event?
Houston Station, yes, we're ready for the event.
European Space Agency, this is Mission Control Houston. Please call station for a voice check.
Station, here is Claudie Agneray in Paris. How do you hear me?
Claudie, this is Space Station. I hear you 5 by 5. I'm very happy to hear your voice on the loop, Claudie.
Bonjour Thomas, on est vraiment très très
Thomas, we're very happy to be able to talk to you. This is a name that for the 350 academicians of the French Academy. There are hundreds of children listening in. They're here, they want to talk to you, they have questions, and they'll be very happy to post these questions to you. And I'm very happy to be able to present them to you, to hear your voice. Hello, Thomas. My name is Odette, and my question is, in space, what is the schedule that you adopt? And what are you doing right now? Hello, Adele. Thank you for your question. Listen, in space, we on UTC Universal Time. If I look right now, we are at the southern part of South America, and we're just about to cross the Atlantic. In a few minutes, we'll be over Europe.
Bonjour, je m'appelle Viet.
Hello.
Et ma question est,
my name is Viet.
expliquer les causes de la microgravité dans l'ISS.
And can
Pourquoi la microgravité a-t-elle des conséquences sur la masse musculaire et la
And can you tell us what are the consequences of microgravity in the Space Center and what effect they might have on your muscular condition? Well, the cause of microgravity in the ISS is because we are in orbit around the Earth. It's not that we're so high, it's that we're going very fast. And so with a great deal of speed, we go around the Earth in the same way that a parachutist falls around or toward the Earth in a free fall. And so we are in a free fall, in essence falling around the Earth without ever reaching it. So we are in a permanent free fall around the Earth the same way that a parachutist is in free fall. And therefore we don't feel the effects of gravity, even though gravity is always present. This is very interesting to us. For a great number of scientific experiments, these phenomena enable us to study the effect of space on the bones and the muscles and so on. And we compare the physiology of people, of the astronauts, and then make projections about long-term flight through space.
Bonjour Thomas, mon nom
Hello, Thomas. My name is André, and my question is, do you recycle used waters and wastewater, and if so, how do you do it?
Bonjour Gonzalo.
Hello, Gonzalo. It's a very good question. Yes, the wastewater has got to be recycled. You can imagine it's very difficult to bring water to resupply at the ISS, and so we maximize the use of our resources as much as possible, including perspiration and urine and wastewater. You know that when we breathe in and breathe out, we create a great deal of humidity, and this condensation, all of these wastewaters are captured and filtered and processed and re-injected into the potable or drinking water system. So we have about 4 or 5, we're able to recapture a major percentage of our wastewater, and this is how we are able to maintain our water supply at a sufficient level. This also has applications on Earth, so as to be able to effectively manage water resources on Earth. It's important for us in space, but it's also important on Earth, so that we're able to apply this technology on Earth.
Bonjour Thomas.
Hello Thomas. My name is Tristan.
Comment sont gérées les ressources en oxygène et en eau? Et comment l'ISS s'est réapprovisionné en matière d'énergie?
How do you keep the ISS energized? How do you keep the energy flowing? Hello, Tristan. Well, the water resources we just talked about, we try to economize it as much as possible, to recycle it as much as possible, because the ISS is a small closed circuit. In effect, we are not able to reach 100% in terms of recycling, and so we get resupplied by space vehicles that reach us, like the Russian, the Japanese. They bring us gas, water, liquid water, and so we're able to transform one into the other. We're able to electrolyze water to produce oxygen, and in this manner we're able to, as we mentioned before, to obtain water from the various activities that people engage in. And about every 2 or 3 months we get resupplied with water and oxygen, and also for clothing and food and spare parts, and this enables us to live in the Space Center to ensure the success of the mission, and also to be able to do our scientific testing and experimentation.
Bonjour Thomas.
Hello, Thomas. My name is Thierry. My question is, how are you able to produce vegetables at that height? And how do you cook them? That's a good question. It's a very interesting question, because we're interested in these processes. So once again, to improve the growth of harvesting and the growth of plants on Earth. But we're also thinking about a trip to Mars in about 20 years. And so we're able to develop techniques for cultivating in space so that we can supply ourselves not only with oxygen and gas and water, but also with food in space for long-lasting space flights. And so we, for example, make sure that we don't have water bubbles that accumulate within the living space. And so we're able to atomize the water bubbles so that we have, in essence, a normal atmosphere. And then we're also able to work with vegetables that we grow and prepare them in a way that we can eat them. Hello, Thomas. My name is Anthony or Antoine.
Durant votre mission de 6 mois dans l'ISS, ainsi qu'à votre retour sur Terre, en quoi cela va-t-il aider la recherche médicale?
How would your 6 months in space help medical research? Hello, Antoine. We've already talked about the effects of weight on the human muscular system. There are muscles that we no longer use when we're in a weightless situation. You can see, for example, I don't use back muscles, thigh muscles to raise myself, and so I have to do sports or activities, physical activities every day to keep my muscles in shape. And here we're able to simulate models of getting old, or also pathological or medical conditions. And here we're able to simulate them and study their effects. But we live in order to live in 3 dimensions, we have to make new connections within our brain. It's kind of like learning how to, for example, ride a bike, where we make new connections within our brain. And we study how all of these activities activate or deactivate the brain cells, for example, as well as the muscles. And we're looking for neurological or nerve-related results that can affect, for example, how we heal people who've been involved in car accidents, for example. We're able also to, we know that, for example, in weight, when there's, as we would have on Earth, that the immunological systems in people are affected negatively. And here in a weightless environment, we're able to study how we're able to control and study the development of viruses, for example. We do a great many things here within a 5 or 6 month period. I can't tell you everything we do, there's no time, but we're involved in a lot of these activities having to do with human health.
Bonjour Thomas.
Hello, Thomas. My name is Martin. If you're able to, well, if you get cut or you hurt yourself, is the effect the same as on Earth? Hello, Martin. Yes, it's almost the same. There are differences, however. We cannot do an operation by opening the human body. It's very complicated on Earth. You can imagine how much more complicated it is here. Blood, for example, would be floating around, and it wouldn't be very controlled as a process or procedure the way it might be on Earth. And so we're able to try to behave in such a way that choose people that are not likely to incur problems that would require operations. Myself, for example, I stay in shape, and I have, like all the others, chosen for my good health and constitution. But we do have instances that we can take. We've been trained to help out with first aid and emergency procedures. If anything more serious comes, of course, we would deal with more serious situations by consulting with doctors on Earth. And if it's really serious, we can actually come back to Earth within a 24-hour period and get down to land in Kazakhstan and be taken by helicopter to hospitals. But I hope that this procedure will never happen in the ISS. It's never happened yet, to have to take somebody back to Earth because they were so seriously ill.
Bonjour Thomas, je
Hello,
m'appelle
Thomas.
Québec et je voulais
My name
savoir
is
lorsqu'on
Quebec.
regarde des images prises depuis l'espace.
I'd like to know about photographs taken from the Earth.
Alors que voit-on
We see
exactement à part la
darks,
Terre,
the
à
darkness
travers
of
les
space.
de l'ISS dans toutes les directions?
And so when you're looking in every direction on Earth, you see lights, but when you're looking up in space, you see darkness. Well, we can see a lot of things through the porthole of the ISS. Most of the portholes are turned toward Earth because the reason that we're here is to do our research to be able to improve life on Earth. And this helps our fellow citizens, our fellow Earthlings who have remained on Earth. There's certain allegorical qualities in the sense that we continue to look toward the Earth. However, a few of our portholes are actually turned toward space. We can see very clearly the Moon and Mars and the stars. We see stars that do not sparkle. They're very fixed and very brilliant. That's because we have no air, of course. And I've taken photographs here of the extreme darkness of space. I've tried to. Other people have been more successful in taking good pictures of space. We know this blue planet that we see is very isolated in this immense dark void of the cosmos, of outer space. But there's not a lot to see. From here, we can see the Earth's mantle of air and atmosphere that protects the Earth, because the Earth itself is very fragile. Looking at it from up here, it sort of gives us a chance to take a certain distance from the Earth and to see how fragile it really is. It brings to our mind ecological consideration, and we need to be able to do what we can to protect the Earth. And it's from here that we're able to see some of the fragility of the Earth and to concentrate on the importance of protecting it.
Bonjour, Monsieur Pesquet.
Hello, Mr. Pesquet. My name is Garçon. How do you do your experiments in orbit before you do the mission? And so how do you then run those experiments that have been prepared on Earth? How do you run them in the space lab? Well, some of these experiments have been prepared for many years before ever coming up into the ISS. You can imagine how difficult it would be to start from scratch up here. And so the various different space agencies from the various countries that are participating in the program prepare the experimentation so that when I come here, I become their eyes, their ears, and with my hands. But all of the intelligence actually remains on Earth, and I basically am their agent here, following their instructions to make sure that the experiments that they have prepared are properly run through my hands, through their instructions. We have to make sure that the materials that we use are not too light, are not flammable, are not dangerous to the astronauts. But these are laboratory like the various ones in Spain, rather in France, the INSER, for example. And this enables us to use the properties of Spain to be able to conduct scientific experiments that we could not do on Earth. And so the various space agencies then give us, as we said, the experimentation procedures that we then apply here in Spain to be able to then run them here aboard the space station, to do them in a safe manner so that the result is almost guaranteed 100%, because we don't like to run into failures here with the experimentation. That's not what we're up here for. And then we send the results back to Earth so that they can then take the results and write up papers and improve science and knowledge and procedures in science on Earth.
Merci, cher Thomas. On a passé toutes les questions.
Thank you, dear Thomas. We've run through all of the questions, but we still have a little bit of time. And so we have a question that we'd like to pose to you. from the minister, who's here, the Minister of State. Now, this visit on the Columbus module, we'd like to see if you can run us through something about the module that you're living in. If you could move from, if we could take a couple of minutes to respond to the questions from the State Minister or State Secretary. Well, we are here in the Columbus module. The space station is over in that direction. We're to the right side of the space station. All around me is the scientific experimentation station. Here on the right, which I like particularly because I've spent a lot of time here last week. This experimentation is called MARES, which studies muscles. It's a kind of device that deploys, and I've taken photographs of it, which are used to very closely measure and monitor the muscles, particularly of the legs. To my left is a research model. It's called Human Research Facility to study the physiology of the human body. We have a gaseous system. We take blood samples. We have centrifuges for the blood. We have places to store the blood. And right next to the camera, maybe you can't see it, but there's a little sort of a light-colored, rose-colored or pink-colored, and that's where we grow our plants. And back over on the ceiling, we always have experimentation called FSL, which studies fluids. At this time, we have a sample of fluid which imitates. I'm not able to touch it. It's there's a mark on a sign on it saying, "Be careful not to touch this experiment." Fluid analysis. On the left, there's an experiment to study radiation that was received by the astronauts. All around me, there are a series of experiments called Matisse, which are resistant to bacteria. And this is why we trained for 7 years, to be able to use every square centimeter of space, or even every cubic centimeter. This is the scientific work that the astronauts do here at the station out in space. A lot of scientific work. Hello, Thomas. Mr. Minister, would you have another question? Thomas, I have a question. I'd like to be able to pass along to you some of the mail that we get for you, if you'll allow me to open. This is the 17th question. A young person would like to know how to become an astronaut. What has he got to do to become an astronaut? So what do you do? What are some of the things you can do to prepare yourself to be an astronaut? Hello, Mr. Minister. Yes, I'll try to pass along my mail, but unfortunately the post office doesn't deliver mail to the Space Center. But I can send and receive by email. But there's you are one of those, Mr. Minister, who does send me emails, as do many other people. And this is the comfort aboard the Space Center that enables us. Believe me, this is much better since the Mir station. We have email, and so we're able to send and receive mail a lot more easily and effectively than we used to. And of course, being able to have a video conference and talk to Earth is another improvement of the new space station that we're working in. And I'm happy to talk to people who are interested in this to the degree that I'm able, of course, to get away from the work that I'm doing, because I think it's very important to explain to young people that you have to work. I don't say that to bother them, but to simply help them realize their dreams. This is what happened to me. A little bit of good luck and a lot of work. It's not easy to do, but everybody who wants to know more about this and who are interested in it, I encourage them also to listen to my social mails, and I promise them that when I have 5 minutes, I try to answer my incoming emails. Thank you a whole bunch, Thomas, to share with us these moments. It's been absolutely a magical experience to be next to you. And so our last farewell to you for now. And we are completely absorbed in what you've been able to present to us. And so again, Thomas, you have completely succeeded in fulfilling your mission, and the French Academy of Science would like to congratulate you on what you've done. And A nice hand for you. Thank you, Mr. Minister. Thank you to everybody. It's been a pleasure to be with you today. Thank you.
Station, this is Houston ACR. Thank you. That concludes the event.
And thank you to all participants from the European Space Agency. Station, we are now resuming operational audio communications.